In this video, I will demonstrate some additional functionalities of Sigma X, mostly those pertaining to integration of Sigma X with Synchro. So I do have two different versions for this. One will be a Synchro 6 export, which is for version 6 and earlier ones. And then the other version is UTDF, or Universal Traffic Data Format 8, which is for Synchro 7 and up. The difference is the Synchro 6 export actually creates 5 different files, and all of these need to be imported into Synchro, while the UTDF 8 and up, they only create 1 file, so it's much easier to do import into Synchro. I also have a version of Synchro 6, which I will use to demonstrate how this exporting function works. Unfortunately, I do not have newer versions of Synchro, but I will show those as well so that you can see how that process works. So for this one, first I'm going to take one typical intersection and then just walk step by step through the process, how this works. So this is one of the old projects I was working on. So this is one intersection for which I have some traffic counts. So this is the intersection of State Street and 400 South in Salt Lake City. So I'm going to start by putting the names of these streets into the input here. And then I need to define all my geometry and volumes. So the approach speeds, actually this one is 30 going eastbound. If I remember correctly, this one is 35. These two are 30, so that is fine. We do have pedestrians at every approach, so we want to enable those. And then define the geometry and volumes. So let's start with the southbound direction. So we have one right turn lane, we have 3 through lanes, and 1 left turn lane. And as I said, typically when I have exclusive right turn lane, I put 50%, just estimation of right turn on that percentage. If you do have actual data, then you can go ahead and put that number in here. So we have 122, then we have 896 going through, and then we have 138 turning left. So that's this approach. Then let's see the westbound approach. We have 1 right turn lane, we have 3 through lanes and 2 left turn lanes. Again, I'm going to change the percentage for right turn on red. We have 93 right turns. We have 762 going through, and then we have 201 turning left. Then we go to the next one. So we have 1 right turn lane, 1 left turn lane, 3 through lanes. And then we have 112 turning right. We have 640 for through, and then we have 127 for left. And then finally, we go to the eastbound approach. So we have 2 left turn lanes, we have 3 through lanes, and we have 1. I forgot to change the percentage of right turn right here. And I'll do the same thing for the eastbound approach. As far as volumes, we have 104 left turns, 697 through, and then we have 304 turning right. So this is pretty much all the input data that we need. We're going to keep this here as default values. We really don't need pedestrian volumes. As I said, in this particular version, it doesn't really do anything. But in some other versions, we do have some delay computation for pedestrians and bikes as well, and also for transit vehicles. So we do have some transit buses on State Street. I believe we have a couple different lines, so we can enter these. But again, for this demo, it's not really important. I'm not going to change the manually left turn treatment, although I know how it looks like. So this is pretty much all the input data. Then I can go to my phase calculation, and I can see how my performance look like. So if you look closely, here's my ring barrier structure. So I do have all those turns in here. If I go to my phase designation, I can see that my eastbound and westbound left turns are protected only because we have 2 left turn lanes. Northbound and southbound are left as protected plus permitted because from the geometry standpoint, there's no reason to do protected only. But from the volume standpoint, we can allow having permitted as well, so that we reduce the delay for left turns. Now, a couple of functionalities I also added. So first, what we can do is optimizing the cycle. And as I said, the way this does is it's simply going to cycle between the minimum and the maximum cycle, find what is the cycle with the minimum total intersection delay, and assign that as our optimal cycle. So if I hit optimize cycle, as we can see, nothing changed in here because it remained exactly the same with the same minimum delay. And then there's this other functionality if I want to revert the original. So in some cases, these two might be different. So if I optimize the cycle, it may find a different cycle length, which will be optimum for minimum intersection delay. But if I want to keep the original one that the sigma x computed, I can just hit this button and revert to the original, and then it will go back to what was originally computed. So here are some performance measures, but the easiest way to see this is actually go to the summary, and then we can see the turning volumes. Here's the phase designation. If you look closely, so we do have protected on left turns eastbound and westbound. We have protected plus permitted north and south. And this is actually how this intersection works in reality. So the left turn designation was correct. And then we can see what are the capacity, what is the control delay, level of service, all that information. And then we can also see how the phasing chart looks like. Another update I did to this particular one is fixing the left turns, especially for those cases where we have very low splits for protected left turns. The previous version was giving some unusually small green display values. So I did fix this in this particular version. So the minimum display value for green time would be 5 seconds, regardless of the length of the split. So this is one fix that I did in this particular one. Another thing that I also want to show, and we'll fix this later. So can also recognize automatically if I have a 3-legged intersection instead of a typical 4-legged intersection. All I need to do, for example, I'm just going to remove these left turns, this number of lanes. I don't need to change the volumes. It will automatically recognize that I don't have any lanes. Then let's say I don't have any through movements here. I don't have any left turns, and I don't have any right turns on the westbound. So if I go to my summary, it will automatically change that, right? So this is my phase designation now. As we can see, we still have protected plus permitted left turn on the westbound approach. And then we only have through phases for eastbound and westbound. This one remained the same phase, but that's just because it is tied to the through movement, but we actually don't have any movement in this case. So if I look closely now, you can see that I do not have any information for this lanes or these turns because I don't have any number of lanes anymore. But I still do have an intersection that will show me exactly how this signal timing is going to look like if I have a 3-legged intersection. So same thing, as we can see now, we have a little bit less cycle length. In this case, we have only 80-second cycle length, which makes sense because it's a 3-legged intersection now. So it operates on a lower number of phases. So in this case, we only have 3-stage plan instead of 4. So this is just another demo that I wanted to show. And let's see if I optimize cycle length. So if I do optimization, as you can see, it actually changed the optimized cycle to 130 seconds. Delay is 9.1 seconds. If I revert to original, it was about 10 seconds. So not really a lot of delay, but this is just because of this new structure of intersection. I'm gonna return these back on as they were, and then we'll go ahead and see how the Synchro export works in this particular case. Actually, I have 2 left turns here, and then I have 3 lanes on this particular side. So let's go back, phase calculation, there we go. So this is what we had before, 110 seconds, 30.5 seconds of delay, intersection delay, and level of service C for this particular input. Now what I'm going to do is to the Synchro export. So actually, I'm going to show you another thing. We can also generate a report in a PDF file, which pretty much corresponds to the report that you would get from Synchro if you run the same thing. So if I generate a report, it will create a PDF file. Here it is. So this PDF file shows all the information about the intersection performance. Again, similarly what you would get from Synchro. It will do movement by movement analysis, and it will also show you the overall information about the performance of this intersection. So the other thing that we're going to go back is I'm going to show you now how the Synchro 6 export actually works in this particular case. So once I have my intersection defined here, I click on the Synchro 6 export, and it will create 5 different CSV files, which will be in the same folder as your Sigma X. So in this case, here are my files: phasing, timing, volume, lanes, and layout. I need all of these to do import into Synchro. So to do this, we go to Synchro. As I said, I have an old version of Synchro 6, which will be okay for this demo. I do data access, and then I usually start going backwards from layout and then back to volumes. Go to layout, and then I select. I find where is my layout CSV file in the same folder. In this case, this is my demo folder. Save, and then I read the file, and here's the intersection. So the next one, I'm going to go to lanes, include volume related data if I have any, select, find my lanes CSV, save, read, and it already gave me my lanes for the intersection. Go to phasing, select, phasing CSV file, read. As we can see, we have 16 records being read from the phasing file. Timing, now to correctly read timing, we need to change the timing plan and name from default to 1, otherwise the import is not going to work properly. Then I select my timing CSV file and I read it. So as we can see, it read the intersection timing for one intersection. And then finally, I go to volume, and I'm going to select my CSV file for volume and read the volumes. So I got this message that it didn't have any peak hour factor, which is okay. We did not use any for this intersection. Close this one, and here's the intersection right here. So this is the same intersection as we have in Sigma X. So if I go, for example, to the lane window, I can see the information, some overall information about the lanes. Then we have the volumes for each movement. I typically like to use the timing window because it gives pretty much everything that you need. So here's the lane assignment, exactly the same as we have in Sigma X. Here are the traffic volumes, permitted, protected left turns, depending on the movement, and then all this other information as well. Here at the bottom, we can see the ring barrier structure for this particular intersection. And if I go to my Sigma X and I go to the phasing chart, it's pretty much the same thing that I have in the phasing chart here as well. If you look closely into the cycle length and delay level of service, so 110 seconds, this is what was imported from Sigma X. Then we have the intersection delay of 29.6 seconds, while Sigma X actually gave us the total intersection delay of 30.5 seconds. So it's in the ballpark, very, very similar value. Level of service C in both cases is level of service C for both software. You can also run, for example, some optimization. In this case, let's say I want to optimize the intersection cycle length. It still found the same cycle length to be optimal one. It did change the splits a little bit, and it did reduce the delay by about maybe 1.2 seconds or something like that. So this is what Synchro can do when you want to optimize the intersection further. So this is how the import-export process works for Synchro 6. Now, I also have versions for Synchro 8 or UTDF 8 and up. So if I go back, I don't want to change the input data. I just want to show the process, how it works. I can only click on the Synchro 8, Synchro UTDF 8 export, and it will create only one CSV file. If I go back to the same folder, there's the file that was created, UTDF CSV file. I open it up, and then within this one file, I have all the information about the intersection. So all I need to do now is follow the similar procedure in, for example, Synchro 8 or 9 or 10. and then just import the data into the software. So the process is pretty straightforward, streamlined, so it works relatively easy and it works well. So this is pretty much the particular version that can do some exporting into Synchro. Again, on my GitHub page, you can find both of these versions for Synchro 6 and earlier ones, or UTDF 8 format for Synchro 7 and up. Soon I will also be uploading some more versions, and I will also create some new instructional videos for those.